Alright, YouTube, I thought we'd kick off the night here with a new lab. This one is actually Chapter 2, Lab 2.1, EIGRP load balancing out of the new Route Lab book. This one's pretty simple to get through. I've already taken the liberty of setting up this lab as far as the interfaces and the loopbacks. As you see here, we have 3 equal serial links between all of our routers. They are all set to 64 kilobit. Other than that, that's pretty much it. Save some time so you didn't watch me configure interfaces for 15 minutes when you want to get to the real meat and potatoes here. So the only thing I haven't done yet is apply the EIGRP to the routers, and then from there, once I have that configured, we'll go on and observe the equal cost load balancing, and then we will do some unequal cost load balancing. So let's get started here. So I'm going to router EIGRP, we're going to put it in 100, and we're going to go ahead and auto summarize this. No big deal. Network 10.0.0.0. We'll do the same thing throughout. EIGRP 100, network 10.0.0.0. And with this one, we can observe the adjacencies coming up and look at the debugs as they come through. So we can do a debug IP routing, debug router EIGRP. Let's see here, what is it? Debug IP EIGRP 100. Now that's done. Do conf t router EIGRP 100. And you can see here, add router 2048. So EIGRP is up on it. We'll do a network 10.0.0.0. We can see a couple adjacencies. There we go. Alright, so here's our 2 adjacencies coming up. Let me move over here. So we have 2 adjacencies, 103.1, which is our router 1, 203.2, which is our router 2. So we have 2 adjacencies, and then it goes into updating EIGRP. We have our tables updating here. It's adding the routes, adding more routes. So you can see it's updating, building up our table here. Deleting one, adding another route because it liked that one better. Alright. So cool. We have EIGRP running now on our 3 routers. We have adjacencies. So on router 3, let's take a look at our routing table, see what we got. We're going to have a mishmash of different routes here because a lot of them are local and we have ones directly connected. But once we are really looking at here are these here. So we have some coming in through router 1 and a couple of them coming through router 2. Alright. Then we have this one. Now this is an interesting one. This is one we're kind of wanting to look at here. We have router 1 and 2 are equal cost load balancing this 10.1.102 route over to router 3. So I'll move this out of the way here. Minimize. So we're in router 3, and to get to 10.1.102, it is load cost balancing between both because both of these links are the exact same speed. As you remember, EIGRP does bandwidth and delay as the primary method of figuring out their path. And through here is the exact same. So with that, it will equal cost load balance. And it'll do 2 links by default. We can set it up to do more but 2 is usually pretty good. So we can take a verifier neighbors, show IP EIGRP neighbors. We're seeing routers 1 and 2. We do the same here, show EIGRP neighbors. Here's routers 102.1. So here's router 1 and 203.3. That would be router 3. And router 1, let's show IP EIGRP neighbors. 103.3 is router 3, and 102.2 is router 2. So, let's go back over to router 3, and let's take a closer look at our link here, or our route to 10.1.102, and figure out exactly why we're getting this equal cost. As I was discussing, we have 2 links that are exactly the same, so it's going to equal cost. 10.102.0/29. So now let's observe the topology table here. Get that a little bit bigger. Alright. So what we're looking at here is our composite metrics between both of these routes. And as you see, they are exactly the same. And essentially, there's more tiebreakers that go through to figure out what route it's going to take, bandwidth delay, reliability, MTUs, ultimately the very last one, that's the 5th one as a tiebreaker. But because all these are exactly the same, and here's our load, reliability, delay. These are all the things that we look at: bandwidth, delay, reliability, load, and MTU is our 5 tiebreakers here to figure out the route that EIGRP is going to take. And you see, comparing here, 4,000, and up here, 4,000, reliability is 255, 255, load is 1, MTU is 1,500. So there is no way for EIGRP to distinguish a tiebreaker for this route, and because of that, it is going to equal cost load balance between both of these links. So hopefully that makes sense there. So what if we do a trace route to the 10.1.102.1? Now you can see here, it goes 10.1.103.1 over here. And then it goes 10.1.203.2. So here's 203.2. And then back to 103.1. So it is bouncing back and forth between this link and this link. 203.1, or sorry, 203.2 and 103.1. So it starts off going up here. I'm sorry, backwards. Starts off going over here. Then it goes up to router 2 to 203.2, and then it goes back to 103.1. Load balancing is equal cost each time. It's sharing its traffic across each link. So what we can do, we can see a full effect of EIGRP, equal cost load balancing. To do that, 10, and we'll do a no IP route cache, and so we're disabling IP route cache for both of our links coming out of router 3. So now we'll do a debug IP packet. If I can spell packet. Alright. So now let's take a look. We'll do a ping to 10.1.102.1 again. Alright, so what we want to look for is we got to kind of parse through here a little bit because there's other stuff going on. IP table ID 0. We have this guy. So it's going to 102.1. Sending full packet. (2.1) stop process packet. 203.3 destination 102.1. So that's sending out to router 1. Sending full packet. 102.1. Then it's going to 203.3. So here's the return. And then it's going off again. And here's our broadcast. So here's we start getting some of the hellos and stuff with our EIGRP. (2.1), 203.3. Yeah. So you can see where it's kind of bouncing through there. Alright. So let's take a look at all of our paths here that we got. And main one looks like none of the other ones have a second path. The only one that we do is for the 102.0/29. For what we can see. So let's do a show IP EIGRP top all links. Now we're getting a little something more here. So some of these are not getting put in here because we look at this. We're not quite getting some of these injected into our routing table as a feasible successor. Close. So let's take a look at show IP EIGRP topology 10.120/30. And that is pretty much matching up. Reported distance that was still higher than the feasible distance, so it doesn't get put into the routing table. So that's why we have to kind of look through the topology, even though it's an alternative path. It doesn't get injected because it's not within the correct distances to be put in there. So let's do a little more playing here, shall we? What we'll do is we're going to ping 10.1.102.1 over here, and while it's pinging, I'm going to shut down the interface of router 1, and then we'll watch it kick over to router 2. So we're going to do ping 10.1.102.1, repeat. So we can keep it up and going so we can watch it fail over. So it's pinging. And int S11. Shut it. Put router 3. It's dropping. Give it a second. And it should pick back up. Come on now. There we go. Alright. What we could do is, let's go back, let's put our route cache back on. That would actually probably help our packets here, where it dropped quite a few. We had to kind of wait for everything to kind of expire out before it kicked over. Alright, let's go back int s10 and IP route cache, and int s11 IP route cache. Alright, so now let's try that ping again. Go back, we will no shut the port. Okay, it's up. It's up. Start our ping again. Shut the port. Only drop one ping that time. So that's a lot better. So that's why we like to have our IP route cache on. Cache up those routes. That way if it happens to blip, we only have just one little blip instead of... How many pings did we lose here? 1, 2, 3, 4, 5, 6, 7. Looks like we lost 8 pings with the IP route cache disabled versus only 1 with it enabled. Good thing to have. Alright. So, now let's play with unequal cost load balancing. So what we want to do is we're going to change up the speed of a couple of these links. We'll make this 128. We'll make this 128. So what we need to do is go into clock rate 2800, and go over to router 1, S11, bandwidth 128, interface S10, clock rate 12800, bandwidth 128, and go to router 2, S10, and do bandwidth 128 on that. So now we have everything configured. So these two links are set to 128, and this is still 64. So now what we will do is let's take a look at the topology table now for the 10120. And 120/30. Right now, only seeing one. We should actually be getting 2 of them. Let's see here, we had 10120 going through 10123.2. That's not what I'm expecting to see. I set my links all up. That's 1110. Okay. And clock rates. Good there. And 2 set of bandwidth. And router 3. I did a clock rate and bandwidth. Okay. Let's do a show up here out. EIGRP. See what we got here. I want to look at 10.1.2. That still looks like that would have been from the 64 kilobit. That should have actually changed quite a bit. Let's do this. Let's rebuild. I'm only seeing one neighbor going down. 10.1.203.2 is router 2. I never saw router 1 go away. I want to see if that link went down on me. No, it's up. Ah. I have an up down. So S10, let's see, should run S1. So we got going on here. Clock rate 128.000. Okay, that looks good. Pretty sure. No, that was good. I was thinking the other IP route cache. Alright. Bandwidth, so let's look at S11 on router 1. Show run at S11. Why? Huh. That's interesting because that was up. I don't remember shutting that down. S11 shut. There we go. I knew something seemed a little fishy there. Alright, that is up. We have our neighbor. So we're going to start getting probably our routing table and topology table is going to change. There we go. That's what I was expecting to see. 10.1.2, so now our metrics have changed. That looks better. There, so you got a little bit of troubleshooting in there with your EIGRP load balancing. How about that? Alright, so what we're going to do is we'll run a debug on our eGrip here, and we'll change the variance to 2. That way we can get an unequal cost of load balancing going on. By default, variance is 1 for our unequal cost. So let's apply this and see what we see here. Variance 2. And I see a whole bunch of stuff spewing out here. And we're looking for route installed. 10120 is 10124. 128, we have route installed for 10120. Origin 10.1103.1, which would be router 1. So now we should be getting a different looking routing table here. There we go. 10120. So now we have another route showing up, even though, look at that, even though that doesn't quite match up. If we did a show IP, show IP EIGRP topology, and we looked at our 10120. There we go. Obviously, these metrics are way higher than what the other one is, but it still installs because as another path that would be the next best path. And since we did variance 2, that will go in there. Let's do a show IP route. Do show IP route 10120. What we're looking at is, let's see, we have 10123.2. We have our route metrics 406400000. Then we have a route metric of 211.52,000. Share count is 48. So next thing we can do, we could do a debug IP packet and ping from router 3 to the 10120 up here with loopback 21. And start viewing load balancing. Alright, so according to our lab book here, let's see here, it wants us to filter debug, and we're going to actually use a ACL to kind of help us out here. And it's just kind of a simple ACL to permit pings going through. So we're going to do access list 100 permit ICMP source SHA echo. Easy enough. Debug IP packet 100. There we go. So debug IP packet 100 ties it to the access list 100. So that way the only thing it's going to see is this ACL when it hits that. And so we're only going to see the pings going through for this IP packet instead of that whole slew of stuff that we had coming through the last time and trying to parse through it. So let's do a ping 10.1.2.1 repeat 50. And it would help if I can type ping right. There we go. So now we're seeing all of our pings going through. Alright, so we want to look for our destination. So here we have serial 10, serial 10, serial 10. Let's see, at one point it should be 0. I'm saying all of them went to serial 10. I don't see them going to serial 11. Parsing through it here. I don't see anything where it went to serial 00. Let's maybe run a little bit more here, see if we can get it to kick over. Oddly enough, I never saw it kick over to serial 11. Oh, pretty much looks the same throughout. Doesn't look like it would bounce out. Let's do a tracer up to 10.121. We still have our route there, right? 10.120. It's still there. Let's do that 3. Let's see the one I went to 121. So let's go 120. So it's there still. There. 011. 010. Ability metric. I'm interested why that is not kicking over. Guess what we could do is while we're pinging, let's do 1,000. I want to try shutting this port down on router 2. I think I shut down the wrong port actually. 10. It's actually 11 on router 1 is the one I need to shut down. Oops. Let's try that one more time. Out and R1 T and S1 1. Let's shut that. Now we're going out 10. Now we're going out 1-1. Interesting that it did not correctly load balance out. I think I might have found some sort of issue within here, because that should have load balanced out. That's something I may have to investigate a little further, but in most cases, at least according to Cisco, that unequal cost load balance should have started after so many pings. It should have started going over to router 2 instead of router 1 on its own. So we might find something a little interesting on that, unless I missed something completely stupid and I'm just missing it because it's midnight, a little tired, kids teething. Yeah, I might be missing something. But textbook though, yeah, for what I see, that should have worked. So there you go. Equal cost load balancing and kind of unequal cost load balancing between 3 routers. So hopefully that helped you out. And I will come back with some more EIGRP labs. I'll keep cranking through these. Probably won't finish another one tonight. But I will do what will be lab 2.2, which is EIGRP stub routing. That one should be pretty easy as well. And then we get to move on to the fun one, the dreaded IPv6 for EIGRP. Hopefully it won't be that painful. But as always, thanks for watching. Like, subscribe, give me comments, give me feedback, let me know if I'm doing something good, bad, something I need to change. And as always, thank you for watching.